Okay, some more problems from section 9.5, and this is number 39, and again we're checking for interval convergence and then absolute convergence and conditional convergence. And if we look at number 39, if we can we take a look at this series, x minus 2 to the n over 10 to the n. If we rewrite it like this, we can see that it's a geometric series, and r is x minus 2 over 10. So this converges only for, remember, the absolute value of r less than 1, so that would be the absolute value of x minus 2 over 10 is less than 1. All right. So we can just rewrite this as our inequality. We can break it up. So the absolute value, so that's going to be negative 1 less than x minus 2 over 10 less than 1. And then we can multiply everything by 10. So we get 10, x minus 2 and 10. This would be negative 10, then add 2. And we get negative 8 is less than x, which is less than 12. So here's my interval of convergence, negative 8 to 12. And it's open because it's a geometric series. Those are always open. And if you look at this, if you take the absolute value, we're going to get the same thing. So this is also converges absolutely. And there are no values of conditional convergence. All the values here on these open intervals are absolutely convergent, or converges absolutely. So you take the absolute value of that, and you're going to be in the same boat. So we have no conditional situations. All right, let's take a look at number 40. Let's put this up here so we can get everything in the frame. All right, here we go. Sorry about that. Okay, so we have n x to the n over n plus 2. Okay, so we're going to start with the ratio test and check for absolute convergence. And we're going to use the limit as n approaches infinity of a sub n plus 1 over a sub n. And this is going to give me this. And again, we're just going to take the reciprocal, and we'll just put the absolute value over the x parts because the n's are always positive. N goes from 0 to infinity, so it's always positive. Okay. So this is what we've got. So this is the absolute value of x to the n plus 1, and I'm going to have n plus 1 and n plus 1 plus 2. So I think you can see all that. And over here I've got n plus 2. And then this is the n x absolute value of x to the n, so that was just the reciprocal. So I just inverted this, multiplied, so that gives me the denominator. Okay, and then we can check our simplification. And this becomes n plus 1 and then x to the n plus x to the first power all over, and then this is n plus 1 plus 2 is n plus 3. And this was the same. And we can cancel the x to the n's. And then I multiply these out. So that times that is that, n squared plus 3n plus 2, and then this n plus 3 times n is n squared plus 3n. And then again, these x to the n's canceled. And then we just have this absolute value of x over here. And if I look at the limit of this, look at my coefficients of my highest degree terms, and those are both 1, so remember the highest degree is 2. So it's a rational expression, so we know the limit will be the ratio of the coefficients of the highest degree terms, so that's 1 over 1, which is 1. So this whole limit is 1, so I just end up with the absolute value of x, that equals L. And remember, this converges absolutely whenever L is less than 1, so that's when the absolute value of x is less than 1, which implies that x is between negative 1 and 1. Okay, so that's our interval convergence, except we need to check the endpoints, so let's check the endpoints and see what happens. And they're negative 1 and 1, so I could try to do both of them about the same, because we're going to check for absolute convergence. converges absolutely. We're going to just check the endpoints and see what happens. Now I'm just going to check it for regular convergence first, but what I'm going to notice is that if I put both -1 or 1, if I take the limit of either of these, a sub n, either this term, this would be the nth term, n over n plus 2, and that's going to be either -1 or +1, it doesn't matter, because if I take the limit of n over n plus 2, what do I get? I get 1. So it's either 1 or -1, depending on the n, and it's not going to oscillate anyway, so it's definitely not 0. So as long as the limit of the nth term is not 0, then the series diverges at x equals plus or minus 1 by the nth term test. Now, if it diverges, it can't converge absolutely, because absolute convergence implies convergence. So if we take the contrapositive of that, if it doesn't converge, then it can't converge absolutely, so we don't have to worry about the absolute convergence. So that's not going to happen at the endpoints, so nothing really happens at the endpoints. So here's our interval of convergence, -1 to 1 open. Absolute convergence is also -1 to 1, and there are no values of conditional convergence. All right? So this nth term test kind of gets the endpoints out of play. Okay, so I hope that helps.